The actual process hazard analysis techniques and application, and I guess we're going to focus on HAZOP. And the OSHA requirements for the process hazard analysis is the employer must use one of the following methodologies. One is what if checklist, and the what if and the checklist combination, and the HAZOP, and the FMEA, which is failure mode effect analysis, and fault tree analysis, or other kind of equivalent methodology. And so we're going to talk about the mentioned methodology in PHA. And the first one is the checklist. Basically, it's just like any checklist. There's a list of the items you need to check for to see if it is safe for a process. It is a very cost-effective way to identify hazard, but however, it's very depend on the experience of the people who develop the checklist. So if we start with a complete checklist, covered all the safety problems, then we'll have a successful PHA. Otherwise, we can overlook a lot of a hazardous situation. And next one is the what if. It just basically it's a brainstorming process. People would think about, okay, what if we have a power failure? What if something goes wrong? So it is again, it's depend on team members' experience, and it can result in incomplete study. But and the next one is a combination of what if and a checklist. It can be used to identify the most common hazard in the process. Often being used in the first PHA conducted on the process, but then will be followed by some detailed approaches like HAZOP or something. And a lot of times when we just have the PFDs, process flow diagram, and without the detailed information like PNID, we'll go through the what if and checklist to decide to see if the process is safe. And the next one is the HAZOP. It is a systematic way to review the process and the operating problems, and it requires interdisciplinary team and also experienced team leader. And I guess the advantage of the HAZOP is you have to go through a set of guide word and also parameter, and so it's avoid possible overlooking of some of the problems. And also you have a team that's from all discipline, and different disciplines have different concerns, so you can see the problem from different view. And that's why this is a preferred process. And the FMEA, which is the failure mode and effects analysis, used to evaluate ways of the equipment or system fails and how the system responds to the failure. And it's not very efficient in terms of identify a big list of failures and also a process with a lot of equipment. Basically, like most of the process we're designing, it's have multiple equipments and many parts, and it's FMEA is not very good in terms of to identify the hazard for a big system like this. And the last one is the fault tree analysis, and it is a deductive technique focused on a particular accident or mean system failure, and provide a method for determining the causes of the event. It is suitable for highly redundant systems and component failure, and fault tree analysis is very time-consuming as well. So here's a table list all the advantages and the disadvantages of each technique. And you can see the what if used for simple and small systems. And it's best to be used for the first pass analysis of larger systems and followed by some detailed analysis. And it is fast and simple. The disadvantage is it's not very thorough, and it relies on the experience of the operators or the people who are conducting the study. And checklist, it can be used for a standard process with a long history, so people have a good knowledge of how the system runs and what may happen, what needs to be taken care of. And it is fast and simple, and it is, can be standardized. The disadvantage is that it's only deal with the past experience based on the past designs. So if we have new designs and new changes, it's not a very good way to identify. The combination of what if and checklist, it can be used for analyze any system where good design practices are already in place. It is fast and simple, and it's more thorough than just the what if technique. And again, it's relied on the past experience and previous designs. And the HAZOP can be used for larger process facilities. It's very thorough, and you basically go through a set, already set parameters, so to avoid overlooking any item. Disadvantage is very boring. If you sit through a HAZOP, you will realize that's one of the problems. And time-consuming, and it says repeatedly looking at the same node many times. Yes, that's true, because each node you have to go through the same parameter, a whole set of parameters. So you do look through a system many, many times. But that's why it's also thorough as well. This is FMECA, I think it's called a failure mode effect critical analysis. It's pretty much the same like FMEA. It can be used at any system in any size. Actually, I don't completely agree with this statement, because for me, I think FMEA is best used for mechanical equipment, basically like conveyor belts or something. You just talk about the equipment failure one at a time. It is very thorough, and also here it said it works well with groups or individual sessions. As a matter of fact, I never had go through any FMEA technique with anyone else. Basically, you're only one person who look at it and produce this huge documentation, and other people review it. So it's not like, to me, it's not the group effort. And disadvantage is long, tedious. It says less boring than HAZOP, but I think it's about the same. FTA as a fault tree analysis. It can be used any system process, and it's very thorough, and yet yes, it is graphical too, because actually at the end you do have kind of something produced like a fault tree, actually like a tree, but it is difficult to apply in group setting, and it's suitable for a single analysis.
Does the client decide what we go through? Any of these procedures, or is that a joint thing?
It is a joint effort, actually. If you have a safety expert, after he sees what's the design and everything, he can find out what is the best way to analyze. But I think for us, mostly we'll go through HAZOP. Yeah, that's why this is our focus for the day. And now we're going to talk about HAZOP. This technique is developed in Mount Division of ICI in Britain, and was based on something called the critical examination techniques. And it's being widely used basically right now. It's everywhere, and I guess it started with the Britain, then European countries, and coming over here too. HAZOP is a team approach with a group of people with various background and expertise. It is a guide or the simulated brainstorming activity, and we'll talk about the guide word later on. So now we're going to talk about when is a good time to perform a HAZOP. HAZOP can be applied either at the initial conceptual design stage when we only have the PFDs. But at this stage, what if is another good effort to do it as well. And the other one, another time is when the final piping and instrumentation diagrams are available. And basically when the design is somewhat firm, so we know what kind of instrumentation, what kind of safeguard we already designed into the system, then we analyze. And at this stage, of course, we can design the process safer and avoid incurring a big cost of any process change, because no equipment is supposed to be purchased. Design is not set until you go through the HAZOP. And the HAZOP can also be used during construction and the installation stage as well, just to make sure the recommendations are all implemented. And can be used during commissioning too, and also because it's an operability study as well, so it can be used during operation to ensure the plant emergency and the operating procedures are regularly reviewed and updated. Next week, we're going to talk about what's required to have for the HAZOP meeting, what kind of documents we need. One is the PFD. So basically, we'll understand what we are designing, and the PNIDs to see the detailed instrumentation valves and everything. And also, we need the layout diagrams as well. So then we can identify, okay, certain equipment should not be in this area, And material safety data sheet, that's of course, because we're dealing with chemical, we have to understand what's the consequences if we have contact with the chemical or we inhale any of the vapors. And also we need to have provisional operating instructions. A lot of times that's not available, and that's why we put into recommendations during HAZOP that, okay, the operating procedures need to take care of this issue, that issue, so that's kind of help them to identify the key issues need to address during when they're writing the operating procedures. Here it says heat and material balances. Actually, for myself, I never used heat and material balances during HAZOP because when you're doing HAZOP, you first to kind of have the presumption that the design is correct. And what we're analyzing is any deviations from our design intention and the consequences from that deviation. And the next one is equipment data sheets, startup, and the emergency shutdown procedures, and see if they are adequately, described what needs to be done during startup and equipment shutdown. And now we're going to talk about who needs to be in HAZOP. First, needs to have a facilitator, and this person needs to be independent, and he or she should not be part of the process team who designed the process, and will be the operators on this process. And the facilitator needs to define the scope of the study and select team members, and plan and schedule the HAZOP, ensure the HAZOP going through a thorough process, and also needs to report on the findings and recommendations from the meeting. And other team members we need to have technical members, we need to have engineer, designer, instrumentation engineer, electrical and safety engineer, etc. And of course, we'll always have the operation personnel person who is familiar with the process, who work at the process we're designing for or implemented on or similar facilities. So he knows, okay, what kind of operating trouble he had before or what needs to be avoided. And we'll have a scribe who is going to record the findings and everything. And we'll have other supporting members if needed. And how to become a good HAZOP participant is, number one is be active. And everyone's contribution is important, and because you are all from different disciplines and you see things differently. And it may not be a problem for the process people, but the equipment group may think, oh, this will be a problem. And also needs to be to the point of avoid endless discussion of details. And a lot of HAZOPs, where a group of engineers with operators, once they identify a problem, they just keep on going and going and talk about the subject and trying to solve the problem. The other one is be critical in a positive way. Be constructive. And also, the last thing is be responsible. And he who knows, let the others know. So share your knowledge and the information to others. So now we're going to talk about the HAZOP process. Process start with first you have to have the PNID and PFDs, and the facilitator and the team member are supposed to understand the process, and then separate the process in study notes, because we know how big our drawing can be. There's like 20, 30 pages easily, and there's no way to analyze everything at the same time. So you need to separate into different study notes that's reasonable size, so people can talk about the area in detail. And once you define the study notes and need to find the design intent for that study node as well. And then we're going to study the deviations from the design intent. And that's by using the guide word and the parameters. So after consider the deviations from the design intention, we need to find out the credible causes. What can cause the deviation? Either a hardware failure or human error, which mostly will be operator's error, and the consequences from this failure. And this is based on assuming the safeguard fail. And now the responsive protection response, like a lot of people will say, once the level goes up, and the level alarm will go off. But level alarm is a safeguard, so that's not consequence. So the consequences need to be considered in different ways, like employee safety, loss of plant or equipment, loss of production, and the liability issues, and the insurability and the public safety, and also have to consider the environmental impact. And then we have to examine and find out what's the existing safeguard that's already in the process, in the design. And from here, we can combine all the information, and we have to decide the risk by talking about how severe this hazard can be, or these consequences can be, and how likely for this to happen. Different equipment have different rate of failures. Pumps may fail like one time every 3 years or something. And operator, a lot of times they are the one really know because they have on-hand experiences. And also likelihood information you can find from literature too. There's a lot of statistical analysis about all kinds of valves and instruments and how often they fail. They study many information, and they're trying to derive the information from there. And also, if we decide this is a higher risk, then we need to have a recommendation action items for people to implement to change on the process. And another thing is we have to record all the information. When we look at each node, we need to look at different mode of operation. Not only just the normal operation condition, we also need to consider reduced throughput operation, and during startup or shutdown, commissioning, and other special situation, not just like when everything runs smoothly. This is the. No, you don't see very well. I think probably the printout is better. This is a table. Basically, on the top is what called the guide word, and the side is the parameter, which is related to your operation or your process. When the guide word are no, less, more, part of, as well as other than, or reverse. Yep. Yep. Yeah, we're going to use that when we do the exercise, because we need to follow this. That's what has all this. And when you apply the guide word to the parameter, it comes up with all the deviations, that's possible deviation. And of course, this is dependent on your process. Different processes have different things, and then you have different parameters you need to talk about. Such as like no flow or low flow, and high flow or high pressure, and those are all kind of deviations from design intent, like tube leak, utility failure, maintenance, during maintenance, and agitation, all that. That's why, it is tedious to go through the entire table and to analyze every note through, about each failure, but that's why HAZOP is very thorough as well.
The process looks like a logical process. Is that all done by human analysis, or it can be done by software?
It is done by human, but there's software to help you to record the information. But you do have the people to analyze it, because it is part of the brainstorming process as well. I don't think computer can do that, right? Because you have to apply your knowledge and thinking about, okay, why do I have this no-flow situation? Is that this valve closed, or we have a tube rupture? That's why I never see the flow downstream. Things like that. So it is a systematic way, but it's also a brainstorm exercise. And then when we find out the deviation and find out the possible causes for the deviation, and we need to determine the risk for such a thing to happen. And risk is a function of severity and the likelihood. And severity is determined, I show the different tables here. And the first table is from, different company have a different guideline in terms of determining how severe a risk is. And over here is one company used this table to decide the severity. Basically, it has multiple areas to consider in terms of safety. Not only the safety issue, if you have a near miss or a first aid case, or you have lost workday or death, and the environmental issue, environmental problem, either it's a near miss or a minor release contained within immediate area of the releases, or it's incidents with measurable impact of offsite. And also, it's considered asset damage and business interruption. When you have not only when you consider severity, not just a tank blow up, then you have physical damage. Actually, if you have something, I have a leak, and I identified it, and so I shut down the system and stopped the production. You lost production. That's a loss as well. So that would be considered as a loss as well. So that's all being considered in here. And what happened to the physical equipment? It's been affected, but it still can be used, or the equipment is out of service in a large area and not manageable, things like that. And also consider about severity. We also talk about the public images for the company as well. If there's no outside coverage, we have a near miss, and no one knows outside the company except we have to record it or something as a near miss, or you just have a local coverage. Or state coverage. And the worst is national, international coverage, like the ones we talk about. Basically, everyone all over the world knows. And so that's all part of consideration for severity. And like I said, different companies consider severity differently because they have different threshold in terms of see how bad it can go. I'm sorry? MM is million. I think M is like it's like this is 10,000.
So this is from $0 to $10 million.
No, 0 to 10. MM is a million, I think, or billion. Oh, sorry, that's the 10 million, and this is billion.
So I think 1 million is
1,000? Okay. Yeah, thanks for your correction. 10 million. Yeah, yeah. I have to check on that because if for a plant to last $10 million, I wouldn't think that's catastrophic. You know, you think about this because with chemical explosion and everything, we can easily blow that. Yeah. And this is another company who considered severity differently, but it's the same way you consider worker safety and also property damages, environmental impact.